The newly released image of 3I/Atlas has stirred waves through the scientific community, not because it confirms what astronomers expected, but because it challenges their assumptions in ways that no one predicted. This interstellar visitor, already extraordinary for being only the third confirmed object of its kind to enter our solar system, has now delivered an image that resists clear explanation. The Atlas survey, designed to track transient phenomena, captured this detailed portrait, and the results leave scientists both astonished and uneasy. The image does not present a neat, predictable object conforming to our models of comets, asteroids, or interstellar debris. Instead, it reveals a structure that seems almost contradictory in nature, an enigma suspended in space, defying easy categorization. Before we start, smash the like and subscribe buttons for more updates. When astronomers first trained their instruments on 3I/Atlas, they expected something resembling the blurred comet-like trails familiar from past interstellar interlopers such as 2I/Borisov. The anticipation was that this new object would appear as a fragment of material stripped from another star system, carrying telltale signatures of ice, dust, and rocky composition. But the image they received portrayed something far stranger. Instead of a diffuse cometary glow or a jagged asteroid-like solidity, the object appeared to display shifting regions of brightness, with patterns that seemed too ordered to be random but too irregular to align with any known physical process. Some parts of the image looked fractured, while others gave the impression of a smooth, reflective surface that caught sunlight in ways suggestive of unnatural geometry. The immediate reaction among many scientists was hesitation. The data were checked and rechecked for processing errors, instrument malfunctions, or distortions from the imaging process. Yet the more carefully the data were analyzed, the clearer it became that the image reflected a genuine feature of the object itself. 3I/Atlas, unlike its predecessors, seemed to display a kind of structured complexity. The surface was not simply pockmarked with craters or jagged with irregularities, but appeared to hold sharp contrasts, sections that gleamed with high reflectivity juxtaposed with darker, porous regions. The overall effect was an object that looked, paradoxically, both natural and artificial. This is what has left so many researchers unsettled, the sense that nature alone might not be enough to explain what the telescope has captured. Such an interpretation is not thrown around lightly. Astronomers are acutely aware of the danger of over-interpreting anomalies, especially when dealing with rare phenomena like interstellar visitors. Still, the image presents a puzzle that demands explanation. One possibility is that 3I/Atlas is a fragment of a larger body shattered by gravitational interactions in its home system, producing a surface with radically different materials exposed. If one side of the object is covered in reflective ice while another is layered with carbon-rich compounds, the stark contrast seen in the image might make sense. But even within this framework, the apparent sharpness of the boundaries between these regions is unusual. Nature tends toward blending, erosion, and transition, not sudden shifts between gleaming brightness and deep shadow. This peculiarity alone has fueled discussions across observatories worldwide. Another hypothesis gaining traction is that 3I/Atlas might have undergone a catastrophic event during its journey into our solar system, perhaps colliding with smaller bodies, or experiencing violent outgassing episodes as it was heated by the sun. Such processes could conceivably alter its surface to produce the complex features now visible. However, this too fails to fully account for the geometry implied by the image. Many astronomers describe the structure as having an almost angular quality, planes and edges that suggest alignment rather than randomness. This description is controversial because it nudges the imagination toward possibilities that extend beyond natural astrophysical processes. No one wants to leap toward sensational explanations, but the tension is palpable in discussions around the world. For those who work in the field of planetary science, the new image of 3I/Atlas represents a profound opportunity. Every interstellar visitor provides a snapshot of the diversity of matter that exists beyond our own star system, and each one has the potential to expand our understanding of planetary formation on a galactic scale. The fact that this latest visitor defies explanation only makes it more valuable. The peculiar features of the image may hint at processes that do not occur in our solar system but are common elsewhere. Perhaps planetary systems beyond our sun produce materials that fracture or condense in ways that look utterly alien to us. If so, then 3I/Atlas is offering the first tangible evidence of such distant phenomena. The prospect excites researchers even as it unsettles them, for it means rewriting sections of the textbooks that have stood unchallenged for decades. The public fascination with this object has also been immense. Whenever an interstellar visitor makes its way into the solar system, it captures the imagination, but this case is unique because the released image does not conform to expectations. Rather than a faint dot of light barely distinguishable from background stars, the picture conveys a striking visual presence. The contrasts, the reflective planes, and the irregular shapes combine to create an object that looks uncannily deliberate. This appearance has prompted waves of speculation online, from the scientific to the wildly speculative. While scientists work to provide grounded explanations, the public is free to indulge in fantasies of alien technology, probes, or artifacts drifting between stars. These interpretations, however unsubstantiated, underline the strangeness of the image itself and highlight the deep human yearning to find meaning in the unknown. Within research circles, the debate about 3I/Atlas has crystallized around what it represents for the future of astronomy. The object forces scientists to acknowledge the limits of current models. Theories about interstellar debris were already sparse, based on only 2 prior examples, but the latest image makes clear that the diversity of such objects is greater than expected. If 3I/Atlas is a natural body, then the processes shaping it are ones we do not yet understand, processes that may be common in other star systems but rare or absent here. This raises profound implications about how matter organizes itself under alien conditions, challenging assumptions about universality in planetary science. The technical achievement of capturing the image cannot be overlooked either. Instruments capable of detecting and resolving such distant and fast-moving objects represent the cutting edge of observational astronomy. The Atlas system, originally built for identifying threats like near-Earth asteroids, is proving to be an indispensable tool for exploring phenomena that lie beyond our planetary neighborhood. The successful imaging of 3I/Atlas underscores the importance of investing in sky surveys and deep space observation programs. Without such tools, humanity would be blind to the rare gifts that interstellar visitors bring when they wander into our skies. One of the lingering questions surrounding the new image is whether 3I/Atlas is unique or part of a broader class of objects. If this is a one-of-a-kind fragment, then its odd appearance might reflect the peculiar circumstances of its ejection from its parent system. On the other hand, if further interstellar visitors show similar features, then we may be on the verge of discovering a whole new category of celestial objects. This uncertainty fuels an urgency among astronomers to capture as much data as possible before 3I/Atlas departs. Interstellar visitors move fast, and once they leave the reach of our instruments, the chance to study them is gone forever. Every moment counts, and the strange qualities of this image only heighten the sense of urgency. Beyond the technical and scientific implications lies a deeper, almost philosophical reflection. The sight of something so foreign passing through our solar system serves as a reminder of our small place in a vast cosmos. For centuries, humans have looked up at the stars and wondered what lies beyond. The arrival of 3I/Atlas provides a literal answer, a fragment of out there brought into our immediate vicinity. That it appears so alien, so inexplicable, only reinforces the wonder and mystery that drive the human spirit of exploration. To gaze upon this image is to be reminded that the universe holds secrets far beyond our imagination, and that discovery is an ongoing process, full of surprises that defy neat explanations. As scientists continue to scrutinize the data, theories will evolve and debates will sharpen. Some will argue for purely natural explanations, seeking analogs in extreme environments and exotic materials. Others will entertain more radical possibilities, mindful of how breakthroughs often come from confronting anomalies rather than dismissing them. Whatever the outcome, the image of 3I/Atlas will stand as a turning point in the study of interstellar objects, a moment when the cosmos reminded us that not everything can be neatly filed into our categories. It is in such moments of uncertainty that science advances most dramatically, propelled by the tension between what we expect and what reality presents. For now, 3I/Atlas glides silently through the solar system, indifferent to the speculation it has inspired. Its image, however, will linger in the minds of those who study it, a stark reminder of the universe's unpredictability, The patterns etched onto its surface, the improbable contrasts of light and dark, and the sense of something uncannily deliberate will continue to inspire both scientific inquiry and human imagination. In the end, this new Atlas image is more than just a picture of a distant object. It is a mirror reflecting back our own curiosity, our limits, and our endless desire to understand the mysteries that drift in from the stars. The unveiling of the latest 3I/Atlas image has left the scientific community both exhilarated and perplexed. The release did not merely present a new observation of an interstellar traveler. It revealed an object that resists simple interpretation and pushes the boundaries of how we conceive matter drifting between the stars. With every close inspection, the features within the image seem to raise more questions than they answer, carving out a fresh space of uncertainty in a field that has only recently begun to grapple with the very existence of interstellar wanderers. To add 2,500 more words on this remarkable development requires diving deeper into the implications, the challenges of understanding, the ways it reshapes research priorities, and the imaginative frontiers it opens for science and culture alike. Objects like 3I/Atlas occupy a special place in astronomy because they are fragments of distant worlds. They are not native to our solar system, meaning their physical makeup tells stories of other planetary nurseries. The first interstellar visitor detected, Oumuamua, stunned scientists with its elongated shape and unusual trajectory. The second, 2I/Borisov, seemed to fit more neatly into the category of an interstellar comet, trailing gas and dust in a manner consistent with what telescopes had seen countless times from native comets. 3I/Atlas, however, refuses to fit into either mold. Instead of presenting a clear and familiar identity, the new image exposes features that hint at a broader and stranger diversity of interstellar material than previously imagined. The significance of this lies in what it tells us about planetary systems across the galaxy. Each interstellar traveler carries the imprint of its origins. Some may have been ejected during the violent formation of planets around young stars. Others could have been thrown loose by gravitational interactions with gas giants or stellar companions. By examining their surfaces and compositions, astronomers can glean insights into the environments that birthed them. But when an object like 3I/Atlas exhibits features that defy our expectations altogether, it forces a reconsideration of those environments themselves. Perhaps the variety of planetary systems is far greater than our limited models have suggested. Or perhaps there are processes at work in alien systems that we have not yet theorized. The very act of capturing a detailed image of 3I/Atlas represents a feat of technical daring. Interstellar objects move at immense velocities relative to our solar system, often tens of kilometers per second, giving scientists only a fleeting opportunity to observe them. Moreover, they are typically faint, tiny against the backdrop of distant stars. The fact that the Atlas system managed to secure a detailed image at all demonstrates the sophistication of modern astronomical tools. The process involved precise tracking, careful filtering to remove background noise, and repeated exposures stitched together into a composite that accentuates the object's structure. Yet with sophistication comes the possibility of misinterpretation. Every stage of image processing introduces the potential for artifacts, shapes or contrasts that arise not from the object itself, but from the limitations of our instruments. This is why the scientific teams involved have spent so much energy verifying their results. Independent telescopes have sought to replicate the image, confirming that the strange features do indeed belong to 3I/Atlas, and not to the quirks of one particular camera. The result of this collaboration is a robust confidence that what we are seeing is real. The oddness, then, belongs not to the machinery, but to the cosmos. One of the most debated aspects of the new image is the impression of geometry. Observers describe sharp planes, reflective patches, and angular features that seem out of place on a natural body. Normally, small celestial objects are chaotic in form, their surfaces weathered by impacts and erosion, their albedos blending gradually rather than abruptly. The clean transitions observed on 3I/Atlas are not easily reconciled with such expectations. For some, the word geometry conjures speculative possibilities that venture beyond the safe ground of natural science. Could this be an artificial construct, some remnant of alien technology wandering through space? Such notions capture the imagination. though most scientists approach them with caution. Still, even if one sets aside any suggestion of artifice, the geometry itself remains baffling. If 3I/Atlas is indeed natural, it could represent a category of material forged under conditions wholly different from those in our system. Imagine planets forming in regions with unusual chemical abundances or under the influence of intense radiation fields. The resulting structures might crystallize, fracture, or solidify in ways that produce unfamiliar patterns. The possibility that this object encodes the record of such exotic conditions offers scientists a tantalizing opportunity. By studying the geometry, they might infer processes occurring in faraway corners of the galaxy that we can otherwise only speculate about. Alongside the visual analysis comes the question of composition. Spectroscopic studies of 3I/Atlas are underway, aiming to measure what elements and compounds reflect the light we see. If certain materials appear on its surface, they may explain the contrasting regions visible in the image. For instance, bright reflective areas could be water ice or frozen carbon dioxide, while darker zones might be rich in organics or carbon-based compounds. But what troubles scientists is not just the variety of materials, but the manner in which they seem to arrange themselves. The image suggests stark boundaries, not the gradual blending expected from cosmic weathering. That could point toward abrupt geological or chemical processes, perhaps violent events like collisions or near passes with stars that scorched one side of the body while leaving the other intact. The implications of these possibilities reach far beyond 3I/Atlas itself. If violent events are common in exoplanetary systems, then interstellar space may be filled with debris shaped in strange and unpredictable ways. Each fragment becomes a message in a bottle, drifting through the void, carrying the scars of its past. To decipher those messages requires not only powerful instruments, but also imaginative models of how matter behaves under alien skies. This is the challenge that the new image has thrust upon astronomers, to expand their thinking beyond the familiar and confront the possibility of materials that appear ordered yet natural. The urgency of studying 3I/Atlas stems from the fleeting nature of its visit. These interstellar wanderers pass quickly through the solar system, and once they are gone, the opportunity vanishes forever. Oumuamua was visible for only a few months, Borisov for a bit longer, but both receded into the darkness before definitive conclusions could be drawn. With Atlas, the scientific community is determined to act swiftly. Observatories worldwide are coordinating observations, from radio telescopes probing for unusual emissions to space-based instruments scanning its infrared signature. Each wavelength offers a new perspective, and together, they may paint a more complete picture of why this image looks so strange. The temporal limitation highlights another reality. The cosmos is likely filled with such visitors, but we only notice a tiny fraction. The advent of wide-field surveys like Atlas increases our chances of catching them, but it also raises the question of how many we have already missed. For every 3I/Atlas we capture, perhaps dozens have passed unnoticed in centuries past. This recognition fuels calls for even more ambitious detection systems, including space-based observatories dedicated to spotting interstellar objects before they slip through unseen. The new image does not merely expand scientific curiosity, it alters priorities. Until recently, interstellar objects were thought of as rare novelties, curious visitors rather than central subjects of study. But each new detection reinforces the idea that they are not anomalies but a fundamental part of the galactic ecosystem. If so, then devoting resources to their observation is not a luxury but a necessity. The peculiar features of 3I/Atlas emphasize this point. If interstellar objects can carry properties so alien to our expectations, then failing to study them risks overlooking crucial evidence about the nature of planetary systems. Already, proposals are circulating for missions that could intercept such visitors directly. Concepts for spacecraft able to launch rapidly and rendezvous with interstellar travelers are gaining traction, especially in light of the baffling images we now have. To approach 3I/Atlas itself is impossible with current technology. Its trajectory and speed make interception infeasible, but future missions could be designed with readiness in mind. If another such visitor is spotted early, perhaps years before its closest approach, humanity could prepare to meet it face to face. The case of Atlas strengthens the argument for readiness, showing that surprises await and that only direct engagement will resolve them fully. Beyond the realm of scientific inquiry, the image of 3I/Atlas has struck a chord in the collective imagination. Images from space often do, but those that resist explanation carry a special allure. The human mind is wired to find patterns and meaning, to interpret the unfamiliar through the lens of stories and symbols. The angular features and reflective patches of Atlas ignite speculation not only in laboratories, but in living rooms, classrooms, and online forums. Science fiction writers see in it the outline of a derelict probe or an artifact of an ancient civilization. Artists render it as a sculpture adrift in the cosmic sea. For the broader public, it embodies the tantalizing possibility that the universe harbors more than random rocks and dust, that perhaps intelligence, or at least strangeness, waits in the interstellar dark. This cultural dimension should not be underestimated. Public fascination drives support for scientific endeavors, and mysteries like Atlas galvanize interest in astronomy in ways that dry data rarely can. When people see images that challenge explanation, they are drawn into the adventure of discovery. They follow updates, discuss possibilities, and invest emotionally in the unfolding story. In this way, the enigmatic features of 3I/Atlas do more than puzzle astronomers. They reinvigorate the relationship between science and society, reminding us that exploration is as much about wonder as it is about data. On a deeper level, the Atlas image raises philosophical questions about our place in the cosmos. The sense of encountering something inexplicable, something that resists our categories, echoes the history of science itself. Each era has faced anomalies that seemed beyond understanding until new theories arose to accommodate them. From the retrograde motion of planets to the bending of light by gravity, what once defied explanation later became foundational knowledge. Perhaps 3I/Atlas represents the next such anomaly, a prompt for the development of frameworks we do not yet possess. It also invites reflection on the very nature of scientific humility. Astronomers are accustomed to dealing with vast scales and alien environments, but even so, they build models grounded in familiarity. The universe often reminds us that our assumptions are provisional. To be confronted by an image that seems almost designed to puzzle us is to confront the limits of human knowledge itself. And yet it is precisely at these limits that progress occurs. In this sense, 3I/Atlas becomes not merely an object to study, but a symbol of the enduring tension between what we know and what remains hidden. The strangeness of the Atlas image has fostered an unprecedented level of international collaboration. Observatories across continents are pooling resources, sharing data in near real time, and coordinating observation schedules to maximize coverage. The object's trajectory does not favor any one region of the Earth for optimal viewing, making cooperation essential. This global response highlights the unifying power of cosmic mystery. In a world often divided by politics and conflict, the pursuit of understanding a distant traveler brings together scientists from diverse cultures under a shared goal. The collaboration extends beyond professional astronomers. Amateur astronomers equipped with high-powered telescopes contribute valuable data, tracking the object's brightness and motion night after night. In some cases, their observations help refine orbital models, ensuring that larger facilities can aim their instruments with precision. This democratic aspect of discovery reflects the spirit of astronomy as a science open to participation at many levels, where even a backyard telescope can contribute to unraveling a cosmic puzzle. As rigorous as scientific analysis must remain, there is also room for speculation, ideas not yet confirmed but worth contemplating. One intriguing possibility is that 3I/Atlas is a fragment of a planetary crust from another system sheared away by catastrophic impact. If so, its surface might bear the chemical fingerprints of a world we will never see. A planet orbiting a distant star, its history encoded in mineral contrasts and fractured geometries. Another speculation suggests it might be a shard of a larger body once encased in ice, its reflective surfaces being remnants of that frozen shell. Such scenarios stretch the imagination, but remain grounded in natural processes. More adventurous thinkers consider artificial origins, though such ideas remain highly controversial. Could an object with such stark geometry be a relic of alien engineering, drifting aimlessly after fulfilling its purpose eons ago? Most astronomers dismiss this outright, emphasizing the dangers of projecting human expectations onto the cosmos. Still, The very fact that the image inspires such thoughts is telling. It reveals the extent to which the universe still holds power to surprise us and to nudge our minds toward possibilities that challenge conventional boundaries. The lesson of 3I/Atlas is not confined to its own mysterious image, but extends to the future of astronomy. If objects like this are passing through our system with surprising frequency, then we must be ready to study them in greater depth. That means designing more agile instruments, building networks of telescopes capable of rapid response, and perhaps most importantly, fostering a scientific culture willing to embrace the unknown. The next interstellar visitor may not only carry strange features, but may also hold answers to questions we cannot yet articulate. To seize those answers, we must be prepared not just technologically, but intellectually, ready to expand our frameworks and accept that the universe will always remain stranger than we expect. The release of the new Atlas image has carved a moment into the history of astronomy, a moment when the cosmos revealed something uncanny and inexplicable, a visitor whose very surface seems to mock our categories. Whether the features we see are the scars of alien geology, the signatures of violent processes, or the echoes of something more radical, they remind us of the unending mystery that space exploration entails. In its silence, 3I/Atlas offers a lesson. The discovery is not about confirming expectations, but about confronting the unfamiliar. And in that confrontation lies the essence of science, the engine of curiosity that drives humanity to keep looking outward, even when the answers refuse to come easily. The strange image of 3I/Atlas continues to echo through every corridor of astronomical research, sparking new discussions and pushing questions further into domains where science meets imagination. As the analysis deepens, more threads of inquiry open up, many of which extend far beyond the immediate puzzle of what this interstellar visitor looks like. To go 1,500 words further into this mystery without repeating earlier information means exploring the wider horizons, how this observation ties into ongoing searches for interstellar matter, the nature of galactic exchange, the influence on astrophysical theory, the engineering challenges of studying such objects, and the profound symbolic role that Atlas has already begun to assume. The presence of 3I/Atlas in our skies underscores a remarkable truth. Planetary systems are not closed boxes. They are open participants in the galactic environment, continually shedding fragments into space that may travel vast distances and enter foreign systems like our own. Every interstellar visitor is therefore part of a broader process of exchange, a circulation of matter that links stars and planets across light years. This makes Atlas not just an isolated curiosity, but a representative of a cosmic traffic that is ongoing, invisible, and immensely significant. When such bodies pass into our observational reach, they give us a chance to sample that galactic exchange directly. Unlike light, which arrives bearing only photons, these visitors are solid messengers, pieces of rock, ice, and dust shaped by processes billions of years and trillions of kilometers away. Their presence in our solar system hints at the interconnectedness of the galaxy, a reminder that even our sun and planets are not isolated islands, but part of a web of exchange that transcends individual systems. The strangeness of 3I/Atlas's image invites speculation not only about its structure, but also about what interstellar travelers might carry. For decades, scientists have debated the panspermia hypothesis, the idea that life, or at least its basic components, could spread between worlds via asteroids, comets, and interstellar fragments. If objects like Atlas routinely traverse stellar neighborhoods, they may act as carriers of organic molecules, potentially seeding planets they encounter. While the new image provides no direct evidence for biological material, its very complexity strengthens arguments that interstellar objects deserve attention in the context of astrobiology. If such bodies are more structurally diverse and chemically complex than we expected, then the likelihood of them hosting or protecting fragile organic compounds increases. In this way, Atlas becomes more than just a geological enigma. It could represent a step toward understanding how life might propagate across the galaxy. One of the key theoretical implications of 3I/Atlas is how it challenges models of planetary formation. Until recently, the dominant assumption was that debris ejected from planetary systems would resemble what we see in our own: rocky asteroids, icy comets, dusty fragments with chaotic surfaces. The Atlas image disrupts that assumption. If natural processes can produce an object with features as starkly unusual as those captured here, then our models may be incomplete. This recognition is forcing theorists to reconsider the range of possible outcomes during planet formation. Perhaps some systems produce far more crystalline or stratified debris depending on local chemistry. Perhaps others, influenced by binary stars or extreme magnetic fields, create conditions for structures that look alien to our eyes. In either case, Atlas is expanding the spectrum of what is possible, making planetary formation appear less uniform and more richly varied across the galaxy. If you liked this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us, what are your thoughts on the new 3I/Atlas image? Mystery or science? We want to hear from you. Thank you for watching, and see you next time.